So welcome back, everybody. This is our this is part 3, or the last part of lesson 26, and this part has to do with polynomial synthetic division. Synthetic division is another way to divide polynomials. So we just did a lesson on long division. We're going to talk about synthetic division, and we can touch on the advantages and disadvantages of both. Okay, so this is question type Q65. And it's the same question we had before. It's what is 4x cubed minus 7x plus 5 divided by x plus 2? And we did this using long division. And now let's approach the same problem using something called synthetic division, which can be a little faster and has some advantages in certain situations. Let's get rid of that. So to use synthetic division, there's a process. There's some mechanics involved here. I'm going to zoom in so my handwriting is decent. First thing you're going to do is set up a little partial box, just a little box like this. And then out next to the box, you're going to draw a straight line like that one. So it's going to look something like this. Okay, within the box, so right inside here, you're going to put whatever c is. You remember we had to figure out c. We had to think in terms of a binomial as x minus c. Right, so whatever that c value is, that's what you're going to put in that box. So we're dividing by x plus 2. So that means c would have to equal negative 2 if our binomial is x plus 2. Negative 2 would also be the value for x that's going to make this equal 0, or the actual root. So that's negative 2. Now along this line, along this space next to that box, you're going to put the coefficients of your dividend, the polynomial that you're dividing into. You're going to put just the coefficients, not the whole thing. So for example, this is our leading term. This is the first term. It has a coefficient of 4, so we're going to put a 4 right here. Now this is something very important. You'll notice that this polynomial is in standard form. It's a degree 3 polynomial, but we don't have an x to the x squared term or x to the 2 term. We go straight from 3 to 1. In synthetic division, we're going to want to put a placeholder for that. So we're going to put a 0 right here to indicate 0x squared. So we're going to think about this as 4x cubed plus 0x squared minus 7x plus 5. And I know it just, 0 times x squared just means 0. So it really doesn't add anything to the polynomial, but it does give us a placeholder for that x squared term, which we need. Okay, then this coefficient is minus 7, and then the constant term just stays what it is, 5. So again, you're just putting the coefficients right here, not the variables or anything. All right, and then your setup is done. Now we're ready to get started. So here's how this works. The first thing you do is that first number, you're just going to drag it down and rewrite it underneath the line, just like this. Okay, pretty simple. Then you're going to do something over and over again. What you're going to do is take this number that's below the line, and you're going to multiply it times the number inside the box. So like 4 times negative 2. Well, 4 times negative 2 is negative 8. And that answer, negative 8, you're going to write right here underneath the next number in line. So again, what you're doing is the number you drop down, 4, you multiply it times what's in the box, and then that answer you put in this next space here. Then what you do is you add the numbers that are in this column. Right, so 0 plus negative 8 is negative 8. Then we're going to run through the process again. We're going to multiply negative 8 times the number inside the box. So negative 8 times negative 2 is positive 16. And so we're going to write positive 16 right here. And then we're going to add negative 7 plus 16 is 9. 9 times negative 2 is negative 18. And 5 plus negative 18 is negative 13. Now what you notice, this looks very similar to the answer that we got in the previous video using long division, and that what we created is the coefficients. We found the coefficients of the answer. And the way you state the answer is whatever degree this polynomial was, the original polynomial, which in this case was a degree 3, because we divided it by an x to the power of 1, the answer has to be a degree 2. So what you do is you these numbers become your coefficients, and you start with 1 degree less. So for example, the first number is going to be 4x squared. And it's squared with a power of 2 because this had a power of 3 and reduced it by 1. So 4x squared, and then you just go down by 1 power of x, minus 8x plus 9, and then our remainder is 13. So minus 13 over, what do we divide this by? X plus 2. Okay, so that, assuming I did everything correctly, that's the same answer that we got for the polynomial long division. And as you can see, this process has some advantages, right? It's faster. Okay, you can do this within a couple of seconds. It uses addition instead of subtraction, and addition has less likelihood of error from things like negatives and stuff, like you have to watch out for long division and long division. So this has some advantages over long division for that reason, and in certain situations it works best. So then the question becomes, well, why have long division at all? Well, there's some situations where long division is better. So like, for example, let's say you're dividing by a more complicated binomial like 3x minus 7. Okay, instead of like an x plus 2. Let's say you're dividing by 3x minus 7. Well, if you're dividing by a more complicated linear binomial, right, then this works better with long division. Because in order to figure out what c is in this case, if you think in terms of x minus c, you're going to have to divide through by 3, right? So this would be like c would be 7/3. Well, if you divide this by 3, you're going to have to divide all these coefficients by 3. Okay, and the setup is it gets very complicated. It's at that point you lose the advantage of the synthetic division, and you're better off staying with long division. So long division still works better for more complicated linear binomials like this one. Also, if your divisor is something that's not even a power of 1, let's say you're dividing a cubic by a quadratic, 3x squared plus 6x plus 8 or something like that. Then if that's your divisor, then that definitely won't work with synthetic division. You have to use long division. Where synthetic division is nice is if you're dividing by very simple binomials like x plus 1 or x minus 7 or x minus 10. Okay, right? You've got some pretty simple binomials that you're trying to divide into your polynomial, and then synthetic division is better. Okay, let's do one more example using synthetic division. This one's a little longer, or a little more complicated. What is x cubed minus 5x squared minus 2x plus 24 if it's divided by x minus 3? This is the answer we should get, and it makes sense that we would end up with a quadratic because this is a cubic because it has a power of 3. We're dividing it by a linear, so the result should be a 3 minus 1, which is 2, which is a quadratic. All right, let's set it up. So synthetic division, you're going to draw the box. Okay, then we're going to put in c, whatever c is from our divisor. Our divisor is x minus 3. Okay, so we think of that in terms of x minus c, which means c is equal to 3. So we're going to put a 3 there. We can also think of 3 as the root. The actual value of x is going to make this 0. So there's 3. Then we put in here, along this space, we put the coefficients of our polynomial we're dividing into, which is our dividend. And now we don't have any missing powers of x. We got 3, 2, 1, and then a 0. No missing powers of x, so we don't have to plug in any zeros to be placeholders. This first term, x cubed, okay, that has an implied, an understood coefficient to be 1. So this would be 1, negative 5, negative 2, and 24. Okay? All right, we're going to put our line under here. And then we start the process. First step would just be to bring down the 1. So 1 times 3 is 3. Negative 5 plus 3 is negative 2. Negative 2 times 3 is negative 6. Negative 2 plus negative 6 is negative 8. Negative 8 times negative 3 is negative 24. And 24 plus negative 24 is 0. Okay, well this is good. We get a 0 as a remainder, which means that what we found, this x minus 3, is actually a factor of this polynomial. And the remaining quadratic would be, according to these coefficients that we found in our answer, would be x squared minus 2x minus 8. And fortunately, that looks like the answer that we were supposed to get over here. Okay, good. So another example of synthetic division. Again, has some advantages over polynomial long division in certain situations. So let me know if you have any questions, and I'll talk to you soon, guys.